Hey Algebra 1 folks, let's do some direct and inverse variation application problems, also known as word problems. So we're going to do the first two together, one direct and one inverse, and then you guys are going to try the rest of them, and of course I will work them out because that's how our video instruction works. Okay, so we're going to start with an inverse variation. So let's read through this inverse variation here on the left. The volume V of a gas kept at a constant temperature varies inversely with the pressure P. Immediately, the first thing that I'm going to do is I'm going to go ahead and jot down the volume varies inversely with the pressure. So that's like saying Y varies inversely with X. That's the relationship where you have the first thing equals the constant of variation over that second thing in that order, varies inversely with. Okay, that is what I want to try to think about. The other thing I can think about is that a volume and a pressure that go together have the same product as another volume and another pressure that go together. So there are two different strategies for me to solve an inverse variation. I can either use the equation for the overall relationship, or I can use this equation or this formula right here where the product of the first pair has to equal the product of the second pair, because that, my friends, is how an inverse variation works. Remember that if I was to take this first equation up here and solve it for K, I'd get K equals V times P. So that product is what stays K for constant. So let's try this problem then. If the pressure is 24 pounds per square inch, so P1, 24, when the volume is 15 cubic feet, and that's the volume, so 15 cubic feet. What will the volume be, so we don't know V, when the pressure is 30 pounds per square inch? So what we have is an equation where I have 15 times 24 on the left-hand side, which is 360, and that equals 30 times V, or 30V. We're going to divide to solve. And when you divide, you get 12. So the volume of that gas at that point will be 12 cubic feet. And again, that makes sense. Oop, not cubic. What am I? Cubic feet? No, cubic feet. Hello. Let's try to get that right. Okay? So that's how we're going to solve an inverse variation problem. Let's take a look at the direct variation problem. Let's read it. The amount of money spent at the gas station varies directly with the number of gallons purchased. So in other words, the amount of money spent varies, let's try that again, varies directly, so equals K times the number of gallons purchased. So that's one way to solve this problem. The other way to solve this problem is I can use the fact that the money and the number of gallons has a constant ratio. So if I have one pair of number of dollars and number of gallons, that has to have the same ratio as another pair that fits in that situation. So I can solve this with either the equation, like we see up here, or with a proportion, which I think for a lot of you will be easier. Now, why again can I use a proportion? Because again, if I solve for K, remember that if I solve for K, I get M over G. And that is what is saying K for constant. Okay, so if I am spending $37.72 on 11.5 gallons, 11.5 gallons, that's going to equal what would I be spending on 8 gallons? Now, you should remember how to solve a proportion. To solve a proportion, you're going to cross multiply and set those cross products equal to each other. So that means we have 37.72 times 8, and that's going to equal 11.5 times M. So again, cross product. So multiply diagonally and set them equal to each other. 37.72 times 8 is 301.76. It equals 11.5 M. Okay, let's divide by 11.5, and we get $26.24. And remember, at the end, we should always express our answer with the appropriate kind of unit. In this case, it's money for this problem, and the previous problem was number of cubic feet. Okay, so each time it's going to be a similar type of problem. So let's take a look at the next two, read them and try them, and then I'll write out solutions. Okay, so number 3, the time it takes to complete a project varies inversely with the number of employees. If 3 people can complete the project in 7 days, how long will it take 5 people? I'm going to pause it and write this out for you. So here it comes. Make sure you pause it and try it yourself, folks. Okay, so here's our answer. If it's an inverse variation, I can again use the products of the numbers that go together in pairs. And that means that I have an answer of 4.2 or 4 1/5 days. Now remember to give the answer in a manner that makes sense. Now you wouldn't say the fraction of a day or 4.2 days or a little bit more than 4 days or any of those would work out. All right, next one. The time needed to travel a certain distance varies inversely with the rate of speed. If it takes 8 hours to travel a certain distance at 36 miles per hour, how long will it take to travel the same distance at 60 miles per hour? Work it out, pause it, work it out, and then check out my answer. All right, guys, here comes the answer. Okay, and we end up with an answer here. Again, inverse variation, so it's the products that are going together. Now notice it does say inversely there in the problem. If you did not read that correctly, then you need to go back and try it again. We end up with an answer of 4.8, which is 4.8 hours, or 4 hours, and let's see, 8/10 of an hour. 1/10 of an hour is 6 minutes, so 8 hours and 48 minutes. And there you have it. Let's try another set. Okay. Number 5, the number of centimeters y in a linear measurement varies directly with the number of inches x in the measurement. Pablo's height is 152.4 centimeters or 60 inches. What is Maria's height in centimeters if she is 64 inches tall? Okay, try it out. Here comes my answer. And it turns out Maria is 162.56 centimeters tall. Jot down any questions you have about that work. Let's work on the next one. The number of revolutions made by a tire traveling over a fixed distance varies inversely with the radius of the tire. A 12-inch radius tire, makes 100 revolutions to travel a certain distance. How many revolutions would a 16-inch radius tire require to travel the same distance? Okay, try it out. And here comes my answer. And there we go. The tire is going to make 75 revolutions. One of the things I want you to do at the end of problems like this is I want you to stop and think about the reasonableness of your answer. If Pablo is 60 inches tall and it's 152 and a little more centimeters, Maria is a little taller, and look, our answer is indeed a little bigger. Okay, we can't quantify exactly how much bigger just in our heads, but we should at least see the direct variation there. And the same thing with this one, with the inverse variation. The tire radius is getting bigger, so the number of revolutions is getting smaller. And that's a quick way to at least check that we were on the right track. All right, let's do let's see if we can do maybe 2 more sets of problems here in this video. Okay, number 7. Karen earns $28.50 for working 6 hours. If the amount M she earns varies with H, the number of hours she works, how much will she earn for working 10 hours? Now, this doesn't say directly or inversely, but we should recognize that in this circumstance, it only makes sense for this to be a direct variation, because the more she works, the more, that looks like a V, the more she works, the more she makes. There we go. All right, so why don't you set that up? I'm going to do the same thing. Pause it and try it yourself. Here comes the answer. And it turns out that Karen's going to make $47.50, which again makes sense. It's almost twice the amount of time she's working and almost twice the amount of money she's making. A bottle of 150 vitamins costs $5.25. If this cost varies directly with the number of vitamins in the bottle, what should a bottle of 250 vitamins cost? And I think this is in your stations activity, so if you've already done this one, I have no problem with you skipping it, but I'm going to go over it anyway. So let me do it, and here comes your answer. And it turns out those 250 vitamins are going to cost $8.75. So now, if you didn't understand that one, which I doubt, I'm sure you did fine on it, now you have your answer for that one when you come to class again for your stations activity. All right, guys, last 2 problems. For a fixed number of miles, the gas mileage of a car in miles per gallon varies inversely with the number of gallons. Stephen's truck averaged 24 miles per gallon, and used 750 gallons of gas in 1 year. In the next year, to drive the same number of miles, Stephen drove a compact car averaging 39 miles per gallon. How many gallons of gas would he use? Again, set it up the way we learned. This one's a little bit tougher, so set it up carefully before you start. And I'm going to go ahead and put the answer on the page now. Here it comes. Now, it did turn out that I had to round off our answer for this one because it comes out to a lovely funky decimal here, but I went ahead and rounded it off to the nearest half gallon and got 461.5 gallons. Well, that makes sense. You're not going to need as many gallons of gas if you're getting better gas mileage. The car is more efficient. That's why it's he bought it, because it's a compact car. It's more efficient. All right, last problem. Wei received $55.35 in interest on a $1,230 on the $1,230 in her bank account. If the interest varies directly with the amount deposited, how much would Wei received for the same amount of time if she had $2,000 in the account? All right, set it up, figure it out. Here comes an answer. So Wei probably should have had that $2,000 in her account. She would have walked away with $90 in interest is the final answer there. So you should be comfortable with these at this point and be able to whip through the rest of that stations activity, no problem. I will see you guys in class.